Okay, let's look at how to write a net ionic equation. But before we begin that, I kind of want to show you why we do it. Okay, so a net ionic equation shows which species in a chemical equation actually react. So here we have an equation that's just a normal balanced equation. And one thing that this one shows is that you have silver nitrate plus Ki gives silver iodide plus potassium nitrate. Now, it looks like if you just read the equation that the potassium and nitrate forms a new compound. Well, that really isn't happening as long as they're in solution. So let's look here. Once you put the silver nitrate into water, it dissociates and it breaks into its ions, silver ions and nitrate ions. So you have silver and nitrate floating around in water. In a second beaker, let's say you put potassium iodide with some water. And so the potassium iodide will dissociate, and in the water you'll have potassium ions and iodide ions floating around. Now, let's say you took this beaker and this beaker and you poured them together into this bigger beaker. Now, what would happen is the Ag and I would chemically bond together and form silver iodide, and it would become it's an insoluble precipitate, and so it would sink to the bottom or float to the top or whatever, but it would form a solid. At the same time, the nitrate and the potassium, they are still aqueous, which means that they would still stay dissociated in the water. They wouldn't chemically bond with each other with water in the beaker. And so you still have potassium and nitrate ions just floating around in water, just like we had over here. We had potassium ions floating in water and nitrate ions floating in water. They really remain unchanged. So what you can do is you can write what's called a net ionic equation. So we start with silver nitrate, and it's aqueous. So I'm going to start with the whole equation here. With potassium iodide, it's aqueous, and then what that will yield is silver iodide. That's the solid precipitate plus potassium nitrate. Now, this is kind of the long way to do it, but anything that is aqueous dissociates when you put it in water, so you write what it dissociates into. So this would be silver aqueous plus nitrate, -1 aqueous. Notice how I'm showing the charges on the ions, plus potassium, it's +1, it's aqueous, plus iodide, it's -1, it's aqueous. That's going to yield AgI. Now I don't break it down because it's a solid precipitate. Plus potassium ion, it's aqueous, so it would dissociate. Plus nitrate ions, it's aqueous, so it would dissociate. Now, anything that remains unchanged on both sides of the arrow, you can cross off. So the potassium ion is aqueous on both sides, so it remains unchanged. You can cross it off. The nitrate ion is aqueous on both sides. It can also be crossed off. Then you write what's left over. And so we have silver. You have to make sure that you show that it's an ion, because it's not just silver with not being an ion. So you got to show that. Plus iodide ion. Notice how I showed its charge. And that's going to give AgI. Now when you get done, double check that the net ionic equation is balanced. 1 silver, 1 silver, 1 iodide, 1 iodide. Now the other thing that you got to do is make sure the charge is balanced. The charge on this side is 0. The charge on this side, a +1 and a -1 cancel each other out. That also makes 0. So that one is done there. All right. So there'll be another video that goes through how to do different types of net ionic equations that will follow this one.